So now let's talk about planes in space. So you're going to need two things. You need two things to write the equation of a plane. And what are those two things? So one, you're going to need a point in the plane. So x1, y1, and a z1. And you're going to need, number two, you're going to need a vector normal, i.e. what that means is perpendicular to the plane. So this vector, I'm going to give it the name n, and I'm going to label the entries as A, B, and C. And so let's think about here our kind of setup. Let me draw a plane here. So imagine I have a plane here, and I have a point on that plane. So let's take this point here and call it our x1, y1, and z1. And I also have a vector that's perpendicular to this plane, so it forms an angle of 90 degrees. Let me give that vector a name, right? We called it n. Here's my point P. So I'm going to take any other point on this plane. Let's call it Q. And this point, I'm going to represent it with an X, a Y, and a Z because it's an arbitrary point. And what I can do is form the vector between P and Q, and that's on the plane. So then this vector PQ is on the plane, and n is perpendicular to the plane. So I know n is perpendicular to PQ. What does it mean to be perpendicular? Well, one thing is the dot product is 0. So now I can plug in here the dot product of x minus x1, y minus y1, and z minus z1 is 0. And now, if I compute this dot product, I will get A, x minus x1, B, y minus y1, and C, z minus z1 equals 0. And this right here, this is called the standard form of the equation of a plane. Now, if you distribute out all these scalars that are here, this A, this B, and this C, you could simplify this to look like AX plus BY plus CZ plus some constant equals 0. And this is called the general form of the equation of a plane. So now that we have these equations, let's look at a problem. Let's find an equation, and I'll say in standard form and general form of the plane containing the points 2, 1, 1, 1, 4, 1, and negative 2, 0, 4. So again, just for convenience sake, I'm going to name these points. Let's go with first one's P, Q, and then the second one is R. So what do I need to write the equation of a plane? I need a point. Well, I have 3 of them, so I got a point, but I need a normal vector, a vector perpendicular to the plane. So what I'm going to do is take this point, these points, and make vectors from them. So I'm going to make the vector PQ, 1 minus 2, 4 minus 1. So this first vector is negative 1, 3, 0. And then PR, so negative 2 minus 2, 0 minus 1, and 4 minus 1, negative 1, 3. Okay, so I have these two vectors, and these vectors are both on my plane. So what I need to do is produce a vector that is going to be orthogonal or perpendicular to both of these. And we have one way of doing that, and that's through the cross product. So to get our normal vector n, what we're going to do is we're going to take PQ, take the cross product with PR. So I, J, and K. And then I'm going to copy in my vector. So the first vector, 3, 0, negative 4, negative 1, 3. And we've computed cross product a few times now. I'm just going to tell you what you get. So the vector n, you should be getting 9i plus 3j plus 13k. So here's our normal vector. So this would be our A, this would be our B, and this would be our C. So then if I want to write this equation in standard form, it would be, we need to pick a point. So which point am I going to pick? It doesn't matter. Just pick one of them. I'm going to pick the point P, 2, 1, 1. So 9x minus 2, 3y minus 1, and 13z minus 1 equals 0. So here's my standard form, my equation of my plane. So now to get it in general form, what you're going to do is you're going to distribute your coefficients. 9x minus 18, 3y minus 3, 13z minus 13. And you're going to simplify. You're going to combine your constant terms here. So you'll get 9x plus 3y plus 13z. And if you combine all those, it would be negative 34 equals 0. And here is my general form for my equation of my plane.